Okay, so as Tom mentioned, my name is Nathan Forrest. I'm the technical director at the California Nevada Cement Association. I'm going to talk about some of the local things going on, some codes, some specifications that we're seeing, and I've got a slide at the end that's going to give you some things. If you're not entirely familiar with this concept yet, you will be, and I'm going to give you some things to keep an eye out for in your projects as they come up. So first up, who's driving this effort? Who's writing these specifications for these projects? Well, the American Institute of Architecture has an initiative out called Architecture 2030 that, as you can see on the screen, calls for drastic reductions in the embodied carbon of the buildings, ultimately arriving at a 65% reduction by 2030 and net zero by 2040. So more aggressive than the 2050 goals that we see from a lot of states and a lot of national organizations, more aggressive than the 2045 goal envisioned by the cement industry here in California, net zero by 2040. Additionally, the Structure Engineers Association has an initiative they call SE 2050, not quite as aggressive on a time scale as the Architecture 2030, but the net result is in these red bars that you see here, showing a steady decline from where we are between 2020 and 2025 here, also zero by 2050. So as an industry, we've got to be able to position ourselves to deliver cement and concrete that will enable architects and engineers to achieve these commitments they've made, right? So what I want to do here is take a look at a handful of project specifications, and in one case a building code, to show you that this isn't something that we're talking about in in an imagination sense. This is something that's already here. We're already living with it. This one is the city of San Jose, just a handful of miles across the bay. For their carbon specifications, they say maximum global warming potential, 250 kilograms CO2 equivalent per cubic meter, right? Very standard stuff right there. This is specific to this massive ADA ramp project that you have, that they're working on. They have 17,000 intersections where they're going to replace all the curb ramps and bring everything up to ADA compliance. So lots of use of concrete is going to take place over several years. And they have every intent, as the technology continues to advance in future years, that 250 kilogram number is going to decline, right? They're going to keep drawing that down. And that's why I would point out that this particular example of a global warming potential limit does not include strength classes or provisions for specific attributes to concrete. I'm going to come to those. Here's another very local example. This is the Marin County Low Carbon Concrete Code. It was adopted by the Marin County Board of Supervisors in 2019. It's got some interesting things about it that I'd like to take just a moment to take a look at. In this column on your left, they've got embodied carbon limits, as would be reported by Type 3 environmental product declarations. So they have classes of compressive strength for concrete in roughly 1,000 PSI increments. They also have some provisions for lightweight concrete in here that come up a little bit higher via an environmental product declaration. In this other column, they've got an alternate means of compliance. That's a maximum cement limit. They recognize that not all concrete producers have the ability to produce a Type 3 environmental product declaration at this type, so they created an alternate path to compliance, which is really nice of them to do. And frankly, this is the only code that I've seen that has an alternate means of compliance like this. Oh, Marin County is on the other side of the Golden Gate Bridge. Yeah, it's also only a handful of miles from here. If anybody's coming to the 323 committee meeting on Tuesday, Mr. Brian Reyes, who works for Marin County, has been charged with administering this building code, will be there to talk about his experience so far. They've been dealing with this for a few years now. So we as a committee are going to get to hear from somebody who's actually living it from an agency perspective. That's going to be an interesting thing. Another very interesting thing about this cement limit is they'll tell you that if you have an environmental product declaration for your cement, and just about all the cements available in this market do, you can scale up the amount of cement that you use by the proportion that that cement is lower than the PCA National Average Environmental Product Declaration for a cement. Does that make sense? That was kind of a mouthful. So the PCA National Average is currently at 922 kilograms per metric ton. If your cement's lower than that by 10%, you can use 10% more than these numbers in your concrete. That's This is also the only place I've ever seen that. So I would say collectively as an industry, we were very uncomfortable with Marin County deciding to be the first agency in California to produce a low carbon concrete code. And now seeing what a lot of other agencies or entities have come up with, they did a really good job. You be honest. Yes, sir.
Yeah, I helped work on that, and there was a lot of participation from local people like CEMEX and Central and some of the people around here.
Yeah.
And that was done because of the lack of familiarity back then and the accessibility of the EPDs.
Yeah.
Yeah.
And still at this moment, at least in my conversation with Brian Reyes, I don't know that there's a producer in Marin County that can generate a Type 3 EPD. And it's been 4 years now. Well, not quite 4, but. So I would say thank you. That was very forward thinking of your group.
Yeah, the targets though were generally like NRMCA national type of data.
Yeah.
So the baseline wasn't set very low on the initial pass, and then their objective was to review it like after 3 years and see
Yeah.
where they can go.
They did just reauthorize this and make only a very minor change in it. I don't believe they changed any numbers yet, but I have seen the code commentary where they contemplated a reduction year over, every few years for code cycle.
So no concrete producer can produce that Type 3?
No, I said that there are no concrete producers, to the best of my knowledge. There aren't any concrete producers in Marin County at this time that have the ability to generate a Type 3 environmental product declaration. Certainly, they all know how much cement goes into their concrete, right? And they know where they get their cement, so they can have an alternate means of compliance. And one other thing here that's not pictured, but I would also consider a best practice, is that Marin County embraced the concept of a carbon budget. That is, the architect or engineer knows how much of each class of concrete is going to be used on that project, so they can add up the total amount of concrete, the total amount of CO2 and or pounds of cement that are acceptable for use on that project. And then as long as the contractor stays underneath that total, they can then shift their carbon around, right? If they have some that they need to make strength early versus some they can make strength later on, the contractor has the ability to adjust that. So another, very forward-thinking thing that the Marin County group did. Here's another one in Sacramento, about an hour and a half, 2 hours up the road. They're replacing the Capitol Annex. This is where the legislators have their offices. If you have the pleasure of meeting with any legislators right now, they're in what they call a swing space. It's kind of a temporary office building where while they tear down the office building that the legislators have been in and erect a new office building. So this is the first publicly procured, state project in California that has had carbon limits. There have been a number of private projects, but not, this is the first one on a state level. So they have, rather than specifically strength categories, although they do list strength, since this is project specific, they list the application, right? Slab on grade, columns, walls, slabs, beams, etc. They list the allowable global warming potential by application. So this could lend itself very well to a performance-based specification where you identify the specific attributes in terms of compressive strength, durability, etc., along with global warming potential limits on a project. Here's one for an office building in San Diego. This is a pretty typical spec. There's one thing that tripped everybody up on this. They listed their global warming potential in kilograms per cubic yard. That's a pretty, I know in North America, here in the U.S., we're used to talking about our concrete in cubic yards, but if you look at the PCR and the EPDs, their values are expressed in kilograms CO2 equivalent per cubic meter. So, be unit consistent, I would say. So all these projects so far have been here in California, and the rest of the folks from around the U.S. are thinking, I'm glad I don't have to deal with that. Ha ha. Here's one from the U.S. government. This is the General Services Administration P100 specification. They updated this September of last year. Anybody wants to put up a building that's using that's procured by the GSA, here are your carbon limits. So this is already here, right? This is national. And although we haven't seen it yet, we are expecting information like this to come from the Federal Highways Administration soon, right? That will likely also come with carbon limits. Yes, sir.
So, I'm fairly familiar with this, and I know that we're making what you would consider to be high-strength concrete, 6,000, 8,000 PSI, under 300. So I don't see these goals as being particularly aggressive at this point.
I think you're absolutely right. I don't believe these are terribly onerous. When folks get the idea that, you know, if a little's a little good, then a lot's a lot of good, and they decide that they want to have a 50% reduction from some benchmark, I think that's where we run into some challenges today, right? Yes, sir.
On a couple of slides before,
Say when.
one more, yes, this one. So any reason why the age of the acceptance age has been limited only to 28 days? It's
Yeah.
the later the low for.
Yeah, that's a little strange. I would agree with you there. I think that this also lends itself to what you could do with a performance-based specification where you have pile foundations, for example. You could look at 42, 56, 90-day acceptance, right? It's awfully difficult to load a pile
So
short of 90 days.
HCI in California doesn't have, in their standard spec, they only have acceptance based on 28 days.
Yeah.
We're doing another job right now for the state that, you know, I've asked the same question on, because that forces you to use a higher total cementitious.
It certainly does.
And anyway, I think that HCI somehow needs to get on board with what California's trying to do.
Yeah, there's a lot of opportunities, particularly on larger projects, to have much later ages of strength and maturity involved, and give your ready-mix producer an opportunity to drive these numbers down more. Was there a question over here? Oh,
There's no 2 over there, which makes something about 56 and 90 days right there.
yeah, there's a lot of opportunities here, right?
See, right?
You-
56 days, maybe extend it to 90 days, the approval from the architect.
Yeah. But they say that, but then they're all 28. It's it's boilerplate, copy paste. All right. So I just put this together to give folks that aren't well versed in this some things that you'd like to see versus some things that you'd not like to see. So the concept of having a carbon budget is very, very helpful. That's something that was talked about this morning in the 301 Sustainability Code, and I believe will be addressed in 318 Sustainability as well. You'd really like for, in addition to, it's fine to set limits on the mix by mix or application by application basis, but the contractors would really like to be able to shift that around, so that they can deliver the project on the schedule that works best for them, right? And I don't think, as an owner agency or as an architect seeking lead certifications or whatever they're after, I don't think you're losing anything by allowing some concrete mixes to be higher than the goals if some others are lower than the goals, and overall the project meets its intent, right? Alternate means of compliance would be really nice, via a cement limit or via the GSA document has some language that it's below that table that I didn't include because it gets a bit off topic. But alternate means of demonstrating how you're being sustainable with your project if you're not able to comply with GWP limits, for example. Reasonable exemptions, very important. If you're in a market, if there's a spec out there that calls for only environmental product declarations and there aren't any concrete producers that can generate environmental product declaration, what? You just don't build, right? So you have to have a path for some exemptions when they're reasonable. And in addition to this, I would say you need to have exceptions for things like a pumpable mix, for a high early strength mix, for an air entrained mix, for a lightweight mix, right? Some of those specs that we looked at just listed concrete by strength class, right? And that's not adequate in my humble estimation. Another thing you'd really like to see is locally applicable benchmarks. You could use the NRMCA national average EPD, which in most cases wouldn't be a great application. You could use an NRMC regional benchmarks, that would be better. You could use something like a Carbon Leadership Forum's recommendations. You could get into the EC3 tool and see what's been produced locally if you're in a mature market. But the more local you can make your benchmark, as for the architects and engineers in the room, the more local information you can base this on, the better. And then on the watch out thing, don't list your GWP limits in weird units, pounds a cubic foot or pounds a yard or something like this. Just stick with the ISO standards, right? Kilograms CO2 per cubic meter, CO2 equivalent per cubic meter. As part of the project team, get buy-ins from everybody particularly if you're seeking high reductions. If you're somewhere, if you're contemplating a 5 or 10% reduction from a regional benchmark, this becomes less important than if you're trying to do something like a 30 or 40% reduction, right? Realize that there are going to be some trade-offs in terms of project delivery and construction schedule and things like this if you're going to strive for extremely low carbon, right? The higher supplementary cementitious materials mixes tend to develop strength at a lower rate, and the architects and engineers need to get that clear with the owner and clear with the ready-mix producers and contractors, right up front. You don't want to go into this not discussing it. And then some things I put in red here, because these should be red flags, right? If you're being asked to deliver a low-carbon mix and you have limits on your SCM options or limits on your cements, you're very likely to very quickly run into a problem, right? Somebody says, minimum 611 pounds of cement per cubic yard, maximum 250 pounds, a kilogram CO2 global warming potential per cubic meter. Those two cannot coexist, right? And it's unfortunate, but we do see examples like that. So those are the things, red flags, like I mentioned. All right, before we move on, any more questions? Yes, sir, right in front.
You have more slides?
No, this is my last slide.
Okay, because I'm Johan Silver, I'm from Sweden, and in Sweden I think there is only one cement producer and they have a more ambitious program. So they want to go to 2030. Today I think they have reduced with 30% since 1990 by improved the kiln, replacing the fossil fuel with waste materials, using SCMs, taking care of the carbonation, this carbon dioxide uptake.
Yes.
But the important step is to go to CCS, carbon capture and storage.
Yes.
How are you going to reach your goals in 2045?
All of those,
without that step?
All of those things are part of our roadmap to carbon neutrality. And we're working very hard right now on alternative fuels, right? Getting away from coal, petroleum, coke, and things like that. Working very hard on the idea of recovering the waste heat energy, right? We know that producing Portland cement is a very, very thermally inefficient process, right? 35% efficient, maybe. There's a massive, massive opportunity there in recovering that waste heat and using it for energy generation and things like that. There's lots of steps.
Are you also planning for CCS?
Yeah, absolutely.
Yeah.
He was asking whether we were planning for carbon capture and utilization storage, and the answer is definitely yes. Yes, sir.
So, I'm from this area, so I'm going to ask a regional question. We had a plant in Cupertino that was closed about 3 years ago, and that severely reduced the availability of cement in our state, or especially in our area, because about 80% of our cement came from that source.
Yep.
We're now importing cement from Malaysia, Indonesia, Mexico. We're getting cement to build with overseas. If that plant hadn't closed, it's likely that they could be in the process right now of converting to type 1L, right?
Certainly.
Because to have 1L in our state, they all have to have it. Our source has to be able to provide 1L, so we don't have to have 3 different mixes for one application, right? If we're going to use 1L, we trial batch that one and we use that for the entire project. What's the path forward now to being able to have type 1L in our region? Because I see other regions converting and we're just not even close.
Well, we're going to hear some about the 1L both.
Can you make sure you repeat the question so we all?
Yeah, the question had to do with the closure of the Cupertino plant, which was right here in the Bay Area and was producing 15-ish% of the cement in California. That closed early on in the pandemic and has not reopened. And to the best of my knowledge, I don't think it's going to reopen. This market now is served almost exclusively by imports. I think a little bit of cement comes up from Southern California, maybe a little bit comes down from Redding, but you're absolutely correct. All the cement here, most of the cement here, is being imported. And the unfortunate aspect about that is the places that cement's being imported from care a bit less about global warming potential than the folks in this room, I believe. Okay.
This is where the legislature could have helped us.
Well, the good news, I think, from the global warming perspective is that Senate Bill 596 that passed, that we supported, treats imports and domestic sources the same in terms of their embodied carbon. So California Air Resource Board is working on that, and it's due to have regulations out in July. If they get to it, who holds their feet to the fire? But that's good news, right? It's going to, from an environmental perspective, imports and domestic sources are the same.
For the bean counters, but it still isn't making the progress that we want to make in terms of lowering embodied carbon going into the environment, right?
I'm not sure. Was there another question in the back, I thought? A couple more. Go ahead, sir.
What are you doing? All of these things were per cubic meter,
Yes.
but you could use, so I'm just like a cantilevered retaining wall. Okay, if you use higher strength concrete using more cement, you use a lot less than if you said, okay, I'm gonna make a gravity retaining wall. It's just a massive hunk of concrete, but I can use lower quality concrete, and so now I just use.
Yeah, design efficiency is definitely a big part of reducing carbon in the built environment, and the fine folks at National Ready Mix Concrete Association talk about and educate on that extensively. I think our group is focused primarily on the materials and a little less so on the design application. Yes, ma'am.
I want to make sure that I heard you correctly. You stated that for one of the specifications, I think you stated, for one of the specifications, that if a manufacturer is able to show, was it their cement or was it their concrete? EPD is less than a target value, that they're able to then use more. Which one is it?
Yeah, that's in this Marin County Low Carbon Concrete Code, and I didn't include the language in here. This is just one of the tables that's in the code. I mean, I could have put the whole thing up here and we could have just dissected it, but
Is it that they're able to use more cement?
cement, yeah, cement. So the max GWP, if you take the EPD of route of compliance, is fixed. If you take the cement route of compliance, if you demonstrate that the cement that you use is lower than the PCA national average cement, currently at 922, then you can use more cement by the scale that it is lower.
Okay, and this is based off of a particular strength class, correct?
Yeah, this is all by strength class. It's a little hard to see back there, but 2,500, 3,004, 5, 6, 7,000, and then over 7,000, and then there's 3 classes of lightweight.
I guess what I'm trying to understand is if the goal is to reduce your carbon footprint, and if a producer is able to show that they're able to meet this strength class at a lower carbon footprint, why is there this allowance to use more? It's kind of,
Well, I think at present, to your point, these benchmarks, these standards are relatively easy to meet now. But if you look at the commentary related to the code, they're going to continue to come down, right? And so the idea is that at some point you might, a producer might not be able to meet, so right now it says 500 pounds of cement for 5,000 PSI. That's pretty easy. You could almost make concrete in your wheelbarrow that would meet that. But what if that says, 200 pounds of cement? That gets a little tougher, right? So you'd like to have an allowance in there to be able to use more of a greener material. Does that address that?
well, that's only if they can prove that their cement is meeting the target, so they will have an EPD.
Oh, certainly, yeah. You have to have a cement EPD to be able to do that.
So if they're doing that, they're already meeting the strength target, right?
They certainly have to meet the strength requirement.
More cement, it's kind of just increasing your carbon footprint when you don't need to. Because
Well, but you're using more of a lower carbon cement, right? It's like driving 10 miles in a vehicle is 20 miles a gallon, or 20 miles in a vehicle is 10 miles a gallon. It's the same amount of fuel.
But you're using more of, let's say, this lesser cement, but they're not basing it off of the cement, they're basing it off of the.
It's primarily off of the intent was for it to be primarily off of the embodied carbon. But again, in that particular market at this time, there aren't producers that can generate that document. And I think, I may not have the most current data, but I think the latest I heard is that in the U.S., only about 20% of concrete producers can generate an EPD.
So the alternative path makes sense, but to me, it's like if you're requiring, if they have an EPD that shows they're able to meet the strength desired at a lower carbon footprint, they shouldn't necessarily be able to increase it. Because
And from a business perspective, they would want to use the least amount of cement possible, right? Cement's not free.
Yeah, question on the front here.
Yeah, you had them for a while, sorry.
Yeah, I was just gonna comment that, I think, to what she's saying, that
the assumption is that, you know, as you just said it right there, people are not going to use more cement than they're required to use. Now, the difference is that different cements from different suppliers are not all equal. So you may have one that is really low carbon, but you maybe don't get quite as good a strength of it, and it takes a little more of it than the other. So it kind of comes out in the wash.
Right. Yeah. Go ahead.
What is the mechanism for the concrete suppliers to demonstrate that the mix design achieve these requirements? Because often the suppliers don't disclose the mix design, yeah?
Well, they have to put the mixed as, oh yeah, if we could, your question was a little hard for the people in the back to hear. He was asking, how do the concrete suppliers demonstrate that their concrete meets the code requirements in terms of GWP? So they do that through an environmental product declaration, and Jim's going to talk about this. He's a concrete producer. But essentially, the concrete producers have to put their information into the environmental product declaration generation tool to get that EPD out, right? So, and they also have to submit that to their clients as well. So, I think there were some more questions in the back. Yes, sir. Oh, I'm sorry. I just handed her the mic. Let's get to her and then come back to you.
How do you account for poor testing? So I can make a very, very low carbon concrete. However, I have a testing lab that doesn't quite follow procedures, so it's going to show that I am below F prime C.
Yeah,
And because of that,
that's a big problem.
it is a huge problem,
Yeah.
but you haven't accounted for it in your slide. So how is that going to be accounted for? Based on that, as a producer, I'm able to produce to meet your specification. However, my testing lab, because they're not following ASTM C31 or ASTM C39 or meet within those qualifications, I have to allow for additional cement to be used to meet the F prime C value.
Yeah, you've got the over-design requirements built into the code, but I think the unfortunate blunt and short answer to your question regarding how the spec is going to address poor testing is that it's not.
It absolutely does not.
No,
So
no,
you still-
no, it does
so you
not, and
still, as a
I
pro-
think it will not,
But as a producer, you're under litigation terms if you don't meet F prime C.
certainly.
So now we have to depend on a testing laboratory to absolutely follow the letter of the law to get to F prime C based on the minimum requirements that we are required to follow.
You're absolutely right, and I don't think there's a producer, an architect, an engineer, or an agency in this room that doesn't have problems with that. And was there one more in the back? Yeah.
How do you verify your EPDs from your import cements?
We haven't seen an EPD from an import cement yet, so I'll have to get back to you.
By Monday, maybe?
Yeah. All right. Check with me on Thursday.
All right.
Karthik, did you have something?
So just to follow up what Julie was saying, basically,
I think could the engineers like enforce that, you know, the standards should be followed in terms of testing cylinders, all that kind of securing cylinders, and because I mean obviously this carbon is a big thing for them, so this is a huge issue, right?
Absolutely.
We got to put more cement to address the low breaks, so they should be in their best interest to do that.
Like it, 2 more.
All right, we're going to keep moving.
All right.
Thank you, Nate. Thank you for stirring conversation. Again, that's what we're really trying to do here tonight. We are talking about hot topics, so I like the heat in here.